Hello, my name is Peter Bentley, and I'm going to talk about SCAPE today. Thanks for joining me. Let me share my screen. SCAPE stands for Searching Conceptual Architecture Prompts Using Evolution. And we're focusing particularly here on conceptual architecture, the early stage of building design, where architects worry about the forms, the shapes, the colors, and take a lot of inspiration from other areas. So evolutionary computation has been used in this area for quite some time, some decades. And those of you who know me know I've been involved in that. But the trouble with evolutionary computation, as good as it is, as creative as it is, that you don't get the kind of realism that you see in the latest generative machine learning methods, such as DALL. But the trouble with DALL-E is it's actually quite hard to use, and you don't get the creativity. DALL-E produces the most predictable outcomes for a given prompt. So you have to be pretty good at writing prompts to get anything useful. And that's not really compatible with the early stages of conceptual design. How do you write something when you don't know what you want yet? So that's why we've created SCAPE. SCAPE combines evolutionary computation with these latest generative AI methods, giving us the best of both worlds. We're using evolution to evolve prompts. So these are our contributions. We have a novel combination of evolutionary computation with generative AI. We're using DALL-E 3 and GPT-4 in this case. It's a novel use of EC for human-in-the-loop LLM prompt evolution. Now, our genes in this case are textual attributes, which you're going to learn about shortly. It's a novel use of LLMs for evolutionary initialization. So we're actually using a generative AI to do the initialization of attributes, to mutate and crossover as well. We made an entire web application with a nice, easy to use interface, so anybody can use it. And indeed, we've had real architects use it. And we compare SCAPE with a vanilla DALL-E 3 in terms of several features that you can read there. So SCAPE operates a bit like an evolutionary art system. We present several options for the user, and they act like the evaluation function. They choose the one they like as parents, which become mutated and crossover to present the next generation. So there's no prompt engineering they have to do to evolve in the prompts. The user provides an initial text prompt comprising just a few words. Everything else is done just by picking those patterns. So we implement it as a web application, and you can see the stack here. We're going to go into details. We considered these particular points when we're designing the user interface. Mainly, we want it to be easy to use. And what does it look like? Well, it looks a bit like this. So let's put in a prompt, an Art Deco rooftop aquarium. Okay, that's all you have to do as your user. And what happens next? Well, the LLM is given this prompt, and it has to derive values for the 6 attributes, which are genes, remember. It has to derive values of architectural style, site, colors, lighting, shape, form, and materials. So GPT-4 tries to extract the values, suitable attribute values for those from that initial prompt. And if there's no clue, if we don't mention color, for example, it has to come up with a random attribute value. And we ask it to output these values in the appropriate JSON format. And in this way, we make real good use of the LLM's ability to extract text, to generate valid text, and to produce correct formatted output. You don't need dictionaries, you don't need lookup tables. It's all coming out of that pre-trained LLM. So once we've done that, it generates the attributes. Here we go. Here's 4 individuals in our population. They're the attributes it has extracted from that initial prompt I just typed in. A rooftop aquarium in Art Deco style. And they get pushed to DALL-E 3. DALL-E 3 actually expands the attributes into a full description down there, and then it generates images. Here's one of them. Looks a little bit weird. But you could kind of call it a rooftop aquarium if you like. This is the first generation. We can probably do better than that. So if we want to improve the images, we can click on that button and we can click a couple of parents. Let's pick that one as a parent and maybe this one as a parent. Then we can rate the attribute values. We like rooftop, we like Art Deco, We like that sort of lighting. Yeah, maybe we like this sort of lighting. We don't like urban high-rises site. And then when we click generate new individuals, we use the LLM to do the crossover mutation. And it's done using those rating values we just put in. We weight the probability of keeping attributes based on whether the user likes them or not. So if we liked them, then we're likely to keep them and mix them together in some kind of sensible way using crossover. Didn't like them, we're more likely to mutate away from them and come up with new random values. We have to give GPT-4 quite some instructions on how to do this. It's not very good at random. If we ask for a random color, it will come up with the same random color, like red, repeatedly. So we have to say, not that, not that, not that, every time, so that it gives us a true random value. But nevertheless, it's making use of GPT-4's knowledge of language to generate these appropriate alternatives and to mix up existing ones. So what happened next? Well, it has done that. It has mutated and crossed over. These are our new values. We've got an Art Deco fusion, for example. We've got a different site. We mutated the sites. We've kept some things we wanted, and these are the new example ones. I mean, this is quite an interesting one, a cylindrical one. Yeah, it's kind of Art Deco, isn't it? So if we carry on, I'll have these two as parents, say what we like, rooftop I want, the colors are okay, the materials are okay here, cylindrical I like, don't want geometric patterns anymore, I think, mutate away from that. And here's the next one. We've got new. So we've had a mutation on the left, Gothic Revival this time, the new values here, and look at the Gothic Revival on the student generator. And here, interesting, this is a rooftop aquarium. Wow. Here's an internal one. You can kind of see the cylinders coming through in various aspects. It's really preserved that idea of cylinders. And so that's quite nice. This is the third generation. We've got some quite interesting images already. So if we think we're done, let's try clicking on I'm done. I'll click the image I like. Here we go. I'll rate them. Yeah, I like everything. I could put some text in, and then we see this, the end of it. So that's the user flow. Pretty nice. Now, as well as this, users can also click on gallery. They can see all the other images. This is what we just generated. These are other people's images. And you can even click in and see the different generations if you want. I haven't shown it. Okay, so here the experiments. We want to investigate the following questions in this work. Firstly, how does SCAPE compare to vanilla DALL-E 3? We're going to compare using three metrics: novelty, quality, and effectiveness. We're also going to ask how good is SCAPE at optimizing, how good is it at exploration, and how do real architects find this tool? Okay, first, let's look at comparing SCAPE to vanilla DALL-E 3 into the novelty. We use pairwise comparison to compare using an objective measure of difference, and the objective measure is actually GPT-4D. So it's giving us a score based on image difference. And you can see when we do that, SCAPE is actually about 66.7% more diverse with more novel images compared to vanilla DALL-E 3. And this is just the first generation of SCAPE. This isn't even when we've gone through. So clearly novelty is good. And we can see this ourselves. If you look at the kind of output that DALL-E 3 produces when we give it a prompt, windmill converted into dwelling, top row of images, well, they're all windmills. They all kind of look like dwellings, but they're all made of the same thing. They're in the same setting. They look much the same. There's no originality here. There's nothing different. Look at the first generation of SCAPE, and everyone is in a different setting, it's different materials, it's different colors, it's different lighting. So SCAPE has more creativity, more novelty. If we compare SCAPE to vanilla DALL-E 3 in terms of quality, think about this one. This is a government building shaped like a big apple. So DALL-E 3 had to go in the first two, the left two images. And I mean, it's stupid, really, don't they? These look like a cartoon. These are not valid architectural concepts. They're just, yeah. Whereas SCAPE iteration 1 and 2, I mean, they're proper buildings. And you could imagine a building and maybe some government wants to spend too much money on the headquarters of some department, and there you go, it could look like that. And after a couple more iterations, the two on the right, you can see some quite interesting images. So clearly quality, very good. How about effectiveness? If I actually wanted to come up with an interesting, useful design, how hard is it for me just to use DALL-E, or how hard is it for me to use SCAPE? So if I use DALL-E, I have to rewrite the prompt every time. So here I'm showing 7 attempts at me trying to rewrite a prompt to get somewhere. And I found it very difficult, I can tell you. For example, right at the end, the difference between attempts 7 and 6, I just asked for a few more colors. And look what I got. I lost all the features that I was actually interested in version 6, and 7 looks completely different. So not useful, not easy to use. Whereas actually SCAPE, from the first iteration, we get quite interesting concepts, and I'm able to preserve the things I like and mutate away from the things I don't like. And I end up with some really creative ideas by iteration 4. Look at the one on the far right. So clearly, this is quite effective. So how about optimization? Can SCAPE optimize? Well, when we look at those users who went through the process and they clicked on I'm done and selected a favorite image and gave us feedback about it, showing that they arrived at something they were happy with, and we look at the average number of good ratings and the average number of bad ratings, you can see good goes up, bad goes down. What about exploration? Well, we can actually assess, again, the difference between the images as we go forward. And as we do iterate, we get an increasing amount of novelty over time. We can also show, if we look at those users who did not click on I'm done, we never really felt that they'd finished, they were just exploring, we don't get quite such a clear improvement of good and reduction of bad. Good does improve, but then it stays steady, which is what you'd expect. We've got good results, but it's consistent. So this is a clear explorative behavior. And again, you can see this. Iteration 1 of SCAPE for derelict outbuilding with one light on, we've got some interesting ideas. By iteration 3, we've got some quite exotic ideas. I would never have thought of those. How about the final research question? How do real architects find the tool? So what we did was we connected to architects on LinkedIn and asked them, would you like to use a tool? And some of them said yes, not everybody, but some of them said yes. And you can see bottom right, here's a little bit of feedback from someone who did try it. Here's a bit more feedback. And again, very positive. In the paper, we talk about all kinds of feedback and we discuss anything that we can improve. So do check that out. But generally, I liked it. And so here are some examples of real images produced by real architects. In bold is their textual input. The text to the right underneath are the attributes that were evolved. And that's the image that was generated. And you can see some really interesting, quite exotic designs, all of them completely feasible. These could be built. Some of them really difficult to build, but they are really quite impressive. The ideas are quite stunning at times. Some quite inspirational ideas. I mean, look at this from musical building. I mean, that really is quite a musical looking building. So, you know, some really interesting ideas generated using SCAPE by real architects. So to conclude, SCAPE combines evolution with the latest generative AI to exploit the best aspects of both. Vanilla generative AI, standard DALL-E, it's actually very difficult to use. It's not got the novelty, it's not got the quality or effectiveness of SCAPE, using human-in-the-loop evolution to generate these prompts. So SCAPE works. It does generate quality results. It makes good use of the language capabilities of GPT to perform crossover and mutation. It carefully injects randomness and giving DALL-E 3, which doesn't have a memory, giving it a memory so that it can actually innovate and be novel, not repeat itself. When tested by independent architects, we've got a very good response. So you can look at this, you can look at the code, and you can try it for yourself. And do you have any questions? Thanks very much for listening.